All right, we're back. We're still on page 63. We're still doing compositions of trig functions and inverse trig functions. And let's see if we can do these. So again, to point out, they're going to collapse together at the same time. So you always lose like one normal and one inverse at the same time. So for example, here in the next line that we write, we're going to lose cotan of inverse cosine because cotan of an angle is a ratio. Like those two are going to combine to give me a ratio. And then I'm going to try to do the tangent of whatever angle, right? Because inverse sine of something is an angle. So I'll be doing the tangent of the inverse sine of a ratio, the tangent of an angle. And then that's going to collapse to just being a ratio. So the final answer will be a ratio because when you do the tangent of anything, the answer is a ratio. You're finding a ratio. So let's see if we can do this. So I'm going to draw my triangle. So the first one I'm going to call theta 1. I usually just just go for it. So cosine is 5/13. 5, 12, 13 is famous. So I need cotan. So this will be the tangent of the sine inverse of cotangent of theta 1. Tangent of theta 1 is 12/5, so cotangent is 5/12. So 5/12. Okay, now what we do, new inverse trig function means new triangle. So we'll draw a new triangle. Ooh, I am amazed that that worked. I'm going to say this is theta 2. And then the sine of theta 2 is 5/12. So 5/12. So the missing side, 12 squared minus 5 squared, which is easy enough, right? 144 minus 25. But just to illustrate, we can also say that it's 12 plus 5 is 17, 12 minus 5 is 7, and we get radical 119, right? Because you get 70 plus 49, so radical 119. So that's our missing side. And now we want to find tangent of theta 2, right? That's basically what we're trying to do, so find the tangent of theta 2. In this triangle, tangent is opposite over adjacent, so it's 5 over radical 119. All right, and we will check that at the end, but I feel good about it. I mean, it might numerically be wrong, but the process was definitely right. So you don't need, obviously, I mean, if you're doing this by hand, you probably don't have enough highlighters to do this. You don't need to highlight these, but I think it really illustrates that they're going to collapse together. So I'm going to find the cosine of this angle. What's this angle? It's the inverse tangent of 20/21. Do I know what angle that is? I have no idea. None at all. The tangent's really close to 1, though, so it's probably close to pi/4, but a little less than pi/4 because tangent's an increasing function. So these are things you can start thinking about. Try to think about things like that, right? I know the inverse tangent of 1 is pi/4. I know that tangent itself is an increasing function. So as the angle increases, the tangent increases. 20/21 is a little less than 1, so the angle should be a little less than pi/4. That's my thought process on that. Does that help me? Not in the slightest. But let's see if we can actually do the problem. So we draw a triangle, and then I'll say theta 1. So the more you have nested, the more triangles you need, basically. So tangent 20, 21. I know this is 29 because 20, 21, 29 is my personal favorite Pythagorean triple, which doesn't really help you other than if you also know my favorite, you'll be able to skip a lot of work. So here we're going to do the sine of the tan inverse of cosine of theta 1. Cosine of theta 1 is 21/29. All right, now I'm going to try to do, this one's going to be not great. I'm going to try to do the sine of the inverse tangent of 21/29. New inverse trig function, right? I mean, it's the same inverse trig function, but we hit it for a second time. New ratio, new triangle. So new triangle, and in this triangle, we have the tangent of, let's call it theta 2. Tangent of theta 2 is 21/29. So this is going to be 29 squared plus 21 squared. Do I have 29 squared memorized? Not really, but I do know that 29 is 30 minus 1, So 29 squared is 30 minus 1 squared. 30 minus 1, I do know how to square, right? It's square the first, multiply them together times 2, and then square the last. So it's going to be 841. So I'm doing 841, and then I could do the same. So 21 squared, right, is 20 plus 1 squared. So square the first, multiply them together times 2, square the last. So 441. So this is going to be radical 841 and 441, 1282. So this is radical 1282. These are the kinds of arithmetic versus arithmetic. That feels like a parts of speech thing. These are the kinds of arithmetic tricks that you find yourself doing. Like if you don't remember something, just know some algebra, and it'll help you out a lot, I think. So I need to find the sine of theta 2. That's basically the question. Sine of theta 2 is going to be 21 over radical 1282. And we'll check that. And if we got that wrong, I'm not really surprised, because that was a lot of arithmetic. All right, last problem on this page. So these are going to combine and go away at the same time. And then these are going to combine and go away at the same time, right? Because we're doing the sine of an angle. Then we're going to do the cotangent of an angle. Those are the two problems that we're essentially solving. So let's do the first one. There's also a lot of like co-function in this problem. So I don't know if that's going to have something to do with it, but it might. Theta 1. Cosine of theta 1 is 12 over 13. So 12, 13, 5, 12, 13. So we're doing the cotangent of the tangent inverse. So this, I think at this point, there's something that's going to happen. I mean, I feel like it's going to happen. So cosine, what am I doing? Cosine, sine of theta 1 is 5 over 13, right? Right. Okay, what do we need to find? We need the cotangent of the angle whose tangent is 5 over 13. If the tangent is 5 over 13, isn't the cotangent just 13 over 5? I think that's going to be our answer. But anytime I'm not really sure, I just do the problem. Like, I'm pretty sure. But here we go, theta 2. And then tangent is 5 over 13. And then keep in mind what we want. We want the cotangent. So I don't need to find the missing side. I don't care what that is. So let's actually like mark that down. We don't need this. So don't solve for it, right? Don't waste your time solving for things that you don't need. This, we just need cotangent, which is in fact 13 over 5, which is what I thought it would be, right? By thinking it through. So make sure you're thinking about the problems that you're doing, not just blindly, madly doing them. You got to make sure you're actually like giving it a little bit of thought, because that's how you get better, right? I mean, it's one thing to just like, while you're doing this page, be able to slog through this page and get the answers. It's an entirely different thing, like 5 months from now, to remember it. And to remember it, you have to have thought about it. So I'm checking D right now, I think. And we get 5 over root 119, which is what we got. Sine arctan cosine arctan of 20 over 21. So we get 21 over radical 1282, which is what we got. And then cotan of, of the arctan of the sine of the arc cosine of 12 over 13. They're annoying to type in. 13 over 5, which is exactly what we got. So the method works for sure. You just have to keep track of what you're doing. Every time you hit a new inverse trig function, draw a new triangle. That's the best advice that you get on this. And otherwise, I would say have fun with them. Like, they're really interesting problems. You can make these if you want. I would recommend what you do is you just on your calculator start typing in something, see if the calculator evaluates it, and then see if you can get the same answer by hand. Because sometimes you'll run into like range issues with the inverse functions. Like you'll write a problem where somehow you have to end up finding like the inverse sine of like 5, and the inverse sine of 5 does not exist. So I guess you run into domain problems, really. It's domain problems with the inverse trig functions. So start by doing it on your calculator. See if your calculator gives you something. If it does, try to do it by hand. Try to match that answer. If it doesn't, it'll give you like an error non-real result. Make a new problem. So anyway, I will be back in the next video to do the next page. So I will see you there.